All right, well, hello, folks, and thanks for joining us on our webinar. I'm Yuri McKee with East Valley Ophthalmology in Mesa, Arizona, and I'm going to talk to you about the HAAG-STREIT surgical microscope today and what makes it special, and tell you why I chose this for the microscope in our surgery center. So the first thing I want to talk about with this microscope is the optical system, because obviously this is the most important part of any microscope. And Spectros is a subsidiary of HAAG-STREIT that makes their optical systems for the microscopes. And this is a well-established company, actually over 70 years of experience, first starting off in 1946. And you can see along this timeline how they've advanced the technology. So what we have here is a company that focuses on optics, that does a first-rate job. Their entire supply chain is in Switzerland. It's a relatively small company, about 50 or 60 employees. And these are specialists. These are craftsmen that take pride in their work and make excellent products. And this gives me a lot of confidence in the product I'm using. As you see, they do medical microscopes, but they also do optics for lasers, for industry, for defense, and others. Their facilities are state-of-the-art. Everything is done in clean rooms. They put a special coatings lab in their facility, which you'll see is very important for good optics in your microscope. And so some of the things about this high-res Neo 900 that I think are important, and this is just a small listing of the important features, are the stereo base and the depth of field, the coatings, and then the red reflex. And I'm going to try to demonstrate some of these important things through some videos that I've taken. Now, if we start talking about stereo base, this is not to be confused with depth of field. Stereo base improves your depth of field and it gives better 3D perception of what you're looking at through your microscope. But you can think of stereo base as the distance in millimeters by which the two optical pathways are separated. So your PD, be it 60 or 65 millimeters, is wider than the main objective lens of the microscope. And what they need to do is take that main objective lens and expand it out to your pupillary diameter or your pupil distance. But if they can start with a wider stereo base, you're going to get better 3D depth perception through your microscope. The other thing I'd like to point out here is the entire optical pathway of this microscope is made of high quality glass and prisms. There is no plastic and there are no mirrors, which degrade the image quality. As you can see, the different well-known microscope companies have different stereo bases. HAAG-STREIT uses the highest stereo base in the industry. So let's take a look at a video here. And this video is of me doing a difficult hydrous stent implantation. I want you to notice that I was in focus before I put the prism on the eye, and I was in focus immediately as the prism went on the eye. So the stereo base is quite large, giving me great depth of focus. And I don't have to focus back and forth in the microscope at all. Now, this patient has a mixed mechanism glaucoma with some peripheral anterior sneaky eye narrow angles and some areas of open angle. So the Schlemm's canal is very tight here, and I'm able to insert the hydrus, but it's not quite in the right spot, and I'm hitting some tight spots within Schlemm's canal. This is making it difficult for me to advance this hydrus. It's going to take a little while to put gentle pressure on this hydrus to advance it past some tight spots in Schlemm's canal. I don't want to have to refocus several times or fight with my microscope to get a good view. And indeed, I'm not having to do that. I'm just not touching the foot pedal at all. And I'm holding the prism nice and steady, and I'm getting a great view, which is making my job a lot easier. Now I'm going to look around a little bit, and you can see I'm in focus all the way from the edge of the pupil right up into the angle. This is a great depth of field, and this makes this procedure that much easier. Here I'm taking down a little bit of the peripheral sneaky eye there, so I can get a little bit better view of the angle. And with enough patience, I'm able to place this hydrus stent, and I'm going to get a real good look at this hydrus stent, and I'm going to see the little windows in that stent within Schlemm's canal and confirm its proper placement. So this is just a demonstration of the excellent depth of field and clear optics that you see with the HAAG-STREIT scope. I wish you could see this in 4K as I record it, because the details even so much better. But there you can see the reflection of the nitinol stent in Schlemm's canal. And so just a really great view with MIG surgery through the prism using the HAAG-STREIT microscope. So the high precision optics, another fact that you really have to look into is how they're made and how they're coated. And the coatings on these optics are very important. As you can see here, without any coating at all, the glass should reflect upwards of 4 to 5% of the light. With a single layer, you're at around 2.5%. But with the multi-coating, anti-reflective coating that the HAAG-STREIT engineers are putting on their optics, we have just 0.3% of light reflected. What this allows you to do is use your microscope at much lower illumination settings. This is much more comfortable for a patient, but it also gives you a better view and more detail and less light reflecting back into your eye, causing potentially miosis and accommodation. So once again, I'm going to show you a video, again, putting in hydrous in. This one goes really smooth, but what I want to do is show you the beautiful colors, the true colors that we're getting here. And this patient has very little pigment in their trabecular meshwork. I can only see Schlemm's canal because there's a slight bit of blood. And so just that little hint of heme covered by trabecular meshwork is all that I have to tell me where to put this stent. And I can see it with this microscope, and I can tap in to Schlemm's canal and insert the hydrous easily. And now I'll just get my final position set, and you should see a really nice position with the windows visible through trabecular meshwork there. Easy to do in large part because excellent visibility through this microscope. The last thing I'll talk about is the red reflex. Now, the red reflex in HAAG-STREIT works a little bit differently than other microscope companies. We have a single pathway for the light beam, and by using high-quality prisms, we can change how much light comes in to which pathway, depending on if we want coaxial illumination or tangential illumination. We can also change the angle of this red reflex. So here you can see that we've moved the prism by flipping the small switch on the front of the scope. And on the same switch, there's a rotary button that will change the angle from a large to a small angle. What this allows us to do is have just one light reflex on the cornea. So there's not 2 or 3 distracting light reflexes, there's just one. And we're using the same optical pathway of the light, which means that we're putting less lenses in the way and we're getting less reflection of light. So the red reflex differs from having a second illumination pathway as seen in other microscopes. Now, the second pathway still gives you a very bright, clear red reflex in other microscopes, but it's only good when illumination is high, and it's only good when you're directly looking into the pupil on the visual axis. Whereas with the HAAG-STREIT, you can have low light illumination and you can be off axis and still get good red reflex. So let me show you here. This is just a basic cataract surgery, and you can see every little strand of viscoelastic that goes in the eye and a brilliant red reflex. You'll notice the eye does move a little bit while I operate, but the red reflex does not flicker. It does not change its intensity. And here's a manual rhexis, and you can see that the eye does move around a little bit. We're a little bit off axis here and there, but I'm getting a great view of the capsule, a great view of the edge of the rhexis, and just a beautiful red reflex during this entire procedure. If you had to tilt your scope for one reason or another, you can change the angle that the light comes in to maintain the red reflex. Here you can see the cataract has been removed. I'm polishing the anterior leaflet of the capsule. And again, excellent red reflex and excellent visibility of the capsule structures, giving me confidence to be able to polish this capsule. So to conclude, this microscope is made in Switzerland. The optics are made in Switzerland. The microscope is made in Germany. It's all high quality optics. It's high quality coatings. It's all glass and prism, no plastic or mirrors. And quite frankly, it is the finest view I've ever had in any surgical microscope. It allows me to do anything from simple to complex cases without worrying about changing my focus, changing my illumination, or fighting the microscope. Instead, it's working with me to let me do surgery and be successful. So I thank you for your attention, and we're happy to entertain questions in the chat line. We'll also have a discussion at the end of this webinar to take questions at that time. So thank you very much for your attention.